Welcome to another episode of MrLopezClasses.com. In this episode, we are going to talk about solar panel systems and windmills. And in the last episode, we are going to talk about hybrid boats. How can we integrate the solar panels, the windmills, in order to create a perfect hybrid boat or a fully electric boat? Yes, it's possible. It's possible. Every day I receive hundreds of emails asking about how to install solar panels in my boat, how to produce electricity in my boat with solar panels, and how to save money with solar panels in my home. With a solar panel, for example, like this, with this equipment, I can produce DC current, positive and negative DC. Depending of the amount of cells, if you check this panel or this one, this is another panel, positive and negative. There are 1, 2, 3, 4, 5, there are 24 cells. Each small rectangle is one cell. If you remember in my class of batteries, each cell, depending on the quality of the electrolyte and the quality of the terminals, produce in between 1.5 and 2.1 maximum volts per cell. And according how you connect the cells in parallel and after that in series with the other group of cells, you can get 12 volts or 24 or 36. In other words, when you have individual cells, each cell produces in between 1.5 volts and 2.1. When you connect those cells in series and parallel, you can get in the output 12 volts or 24 or 36. For example, this one is for 6 volts in the output and it's 0.5 watts. It's a small solar cell. And this solar panel is for 100 watts. The output voltage is 17 volts and the operating current is 5.8 amps. Okay, my friends, let me return to the explanation. What can I do with this electricity produced for this panel? Oh, this is DC. Oh, can I charge one battery with this? Yes, you can. Oh, I can store the electricity produced for this panel in one battery. Yes, of course, you can store the electricity produced for the panel in a battery. That's good. And can I connect more panels like this in series or parallel in order to store more or less amount of amps per hour? Yes, this is the idea. For that reason, in the roof of your home, you can connect 20 panels, 10 in parallel and the other 10 with the previous group of 10 in series. Yeah. Depend of what? How I know if I need more panels or less panels? Okay. Once again, you can store this electricity DC in batteries. You can charge this group of batteries with a group of solar panels. And now, with the group of batteries, with the battery bank fully charged, you can feed the DC panel of your boat, or you can enter that power in an inverter and produce AC current. And with that AC current, you feed the AC panel of your boat. That's clear? The only that I need with the solar panels is charge the group of batteries. With that group of batteries fully charged, I can use that group for different purposes. I can use this group of batteries to feed the DC panel. Oh, I have other group of batteries fully charged with other group of solar cells, and that group can be used to convert in AC with an inverter. And I have other group of batteries. Those batteries are fully charged with a windmill, and that group of batteries is the group of batteries for boat thrusters or electronics. I can store the electricity in batteries, and I can use that amount of electricity for DC purposes on the DC panel, or I can convert that electricity into AC by means of the inverter. This is the class of inverters, chapter 15. Check that episode. I explained that procedure and how efficient is the output and in what cases is recommended or not. This is chapter 15, inverters. All right. Yes, in a boat, it's important install solar panel systems. Why? Because you can keep all the group of batteries fully charged using the solar power. It's free. The only that you need is calculate, design properly the group of panels in order to keep the battery banks fully charged in a short period of time. That's the second secret. For example, this solar panel, this panel in the label say that the capacity of this panel is 100 watts. The output power produced for that panel is 17 volts. The operating current is 5 amps. Let me explain what is the meaning of that. Suppose that I have this panel and I have this battery. This is a marine battery. This battery in the label says that the reserve capacity is 150. This is a battery 12 volts. The reserve capacity is 150. Remember, in order to do calculation for solar panels, I need information related with amps per hour. Reserve capacity, but I explained in my book, in the chapter 4, the formula to convert reserve capacity into amps per hour. It's simple. You multiply the reserve capacity times 0.4167. You multiply 150 times 0.41 and it's 62 amps per hour. You can convert easily reserve capacity into amps per hour if you multiply reserve capacity times 0.41, and this is the amount of amps per hour of this battery. Okay, in this particular example, this battery, the capacity of this battery in amps per hour is 62 amps per hour. And this panel, the capacity of this panel in amps per hour is 5.8 amps per hour. Can I charge this battery with this panel? Yes, you can. But you need to connect the panel through the voltage regulator and after that to the battery for some amount of hours. How much? Let me calculate. This panel produces 5.8 amps per hour. And this battery is 62 amps per hour. Okay, I need to connect my solar panel around 12 hours in order to produce 69 amps per hour. With 69, I charge the battery fully and I have a little 10% higher. Is clear? I need to connect this panel through the voltage regulator, I am going to explain right now, around 12 hours in order to produce 69 amps per hour. With 69, I can charge this battery. In other words, to charge this battery completely, full, I need to connect this panel around 12 hours in order to keep the battery fully charged. This is in case that the battery is practically completely discharged. It's not recommended. You remember what is the recommendation? The rule is discharge the batteries no more than 50%. If not, you damage the batteries, especially if the battery is a cranking battery. Check the episode on the chapter 3, episode number 1 related with batteries. Alright, yes, you can charge any type of batteries with any type of solar panel, depending the amount of hours, depending on the capacity of the solar panel. You can charge the battery quickly or slow, depending on the capacity of the solar panel. For example, this solar panel, the capacity is 100 watts and produce in the output 17 volts. You remember the formula for power? Power is equal voltage times intensity. if I divided the power divided by 17, I have 5.8 amps per hour. This is the capacity of this panel. Okay, with one panel, I can charge this battery fully in around 12 hours. How can I improve? Because 12 hours is too much. How can I charge this battery in 6 hours? Oh, what happens if you connect two of those panels in parallel? If you connect the output of those panels in parallel, right now you have around 12 amps per hour. With 12 amps per hour, probably you only need 6 hours. What happens if I connect 3 panels in parallel? You need 3 hours. 4 panels, you need 1.5 hours. You understand? Depending how you connect the panels, if you connect the panels in parallel, you increase the capacity in amps per hour. If you connect the output of the panels in series, the positive of the first one with the negative of the second one, and in series, you increase the output voltage, and the intensity is equal. In general terms, for purposes of more capacity, you need to connect the output of the panels in parallel. That's the secret. Yes, you can use an array of panels, more or less panels, in order to increase the capacity, and you can charge the battery bank easily. In other words, what is the secret? What is the secret when you select solar panels? The secret is try to buy solar panels with the maximum capacity in watts or in amps per hour. Okay, this one is 100 watts. The output is 17 volts, produce only 5.8 amps. There are other panels of 200 watts or 400 watts or 600 watts. Of course, the output in amps per hour is better. Is clear? This is the procedure to calculate the amount of panels that I need for that group of batteries. Okay, I am going to refresh the procedure. What is the first step when I want to select the panels appropriate for my boat? For your boat, first of all, I recommend flexible panels, like the panel that you have in the screen right now. Those panels, flexible panels, are excellent because you can install those panels on the canopy of your boat because are flexible and are excellent, high quality. This is the first step, if it's for marine application. The second step is try to buy the panels with the maximum capacity in watts. Of course, panels with more capacity in watts are more expensive. But at the end of the day, it's better because you save money, believe me. Alright. The step number 3 is check the battery bank that you want to keep fully charged. Okay, this is my battery bank. My battery bank is composed for 6 batteries, connected 3 in parallel and in series with the other group of 3, 6 batteries. Okay, in other words, that group of batteries is 24 volts. And the total capacity in amps per hour is 600 amps per hour. 600 amps per hour. And I have solar panels of 100 watts. I need minimum 6 panels in parallel in order to get 600 watts, no? But the idea is try to put a little more for safety factor, normally 20% more. Once again, I am going to repeat this specific case. In this battery, what is the capacity of the battery in amps per hour? The capacity of the battery in amps per hour of this battery is 62 amps per hour. And this panel, what is the capacity of this panel? The capacity of this panel is 100 watts. In the label, the panel says that the output voltage is 17 volts. And the current, the operating current, is 5.8 amps. Okay, this is the current that this panel supply in normal condition with a good sun. 5.8 amps per hour. Okay, my battery is 62 and this panel produces 5.8. How many hours I need connect the panel to the battery in order to keep the battery fully charged? Okay, it's 5.8 times 12 in order to produce 69. 69 is good because it's superior to 62 and the battery will be fully charged. That's clear? That's the procedure. It's simple. It's not complicated. The other procedure is, I want to convert the electricity of that group of batteries in AC current in order to provide power for my AC panel. You go to my video in the chapter 15, inverters, and I explain the procedure to calculate the group of batteries according with the capacity of the inverter in watts or kilowatts. That's the second step. Okay, one important thing. If you have a solar panel like this, never try to connect the output of the solar panel directly to the battery or directly to the load, the motor. Connect the output of the panel always through the charge controller. The charge controller is similar to the a.c.r. You remember the a.c.r? The a.c.r receives power from the alternator, power from the battery charger, and send power to each battery bank in order to keep all the battery banks equally charged. It's similar to this one. You remember? The a.c.r. The a.c.r and the charge controller is pretty similar. What is the function of the charge controller? I introduce the panel here, and this one have one output for one battery bank and other output for other load or other battery bank. Input here from the panel, and output and output. It's very simple. There are battery controllers, charge controller, excuse me, like this, according with the capacity of the panels. This one is coming with that panel because it's according with the capacity of those panels of 100 amps per hour each one. Don't forget, never install the output of the solar panel directly to the battery. Always install the output of the solar panel through the charge controller, and from the charge controller you charge the battery bank, or you use for a load or to supply power for a DC panel. This is the charge controller. And don't forget, you can connect the panels in series and parallel in order to create an array with high capacity in amps or high capacity in volts. This is the procedure to select the solar panels for your boat. It's not complicated, it's simple. The only that you need is check the capacity of your bank or your battery bank and check the capacity of the panels that you want to buy. Don't forget, try to select panels with high capacity in watts, and try to select panels with a small area, because remember, one of the inconvenience in our boats is the area. Oh, I want to install it on the deck. Yeah, but my deck is limited. It's not infinite. In your home, probably the roof in your home is big and you don't have problem of space. In your boat, yes. For that reason, you need to select solar panels with a small area and high capacity. Those are the most expensive panels. The cheaper panels, like this, bigger and only produce 100 watts. But it's cheaper. Oh, there are other ones, expensive. The dimension is half of this and produce 300 watts, but the price is 4 times. That's the equation that you need evaluate. At the end of the day, the best panel, the more expensive panel is better. Thank you.